So we'll continue our study of quadratics. This video we're going to solve using the quadratic formula. So let me just talk about this word for a minute. When you are asked to solve, that means you're finding the x-intercepts of the function. So that means you're setting your function equal to 0 and solving for x. And I'll talk about this again, but your x-intercepts have three other terms that are synonymous with that. Your solutions, hence the solving, your zeros of a function, and your roots of a function. Okay, so all four of these things mean the exact same. It means we're setting our function equal to 0 and we're solving for x. So far, how have we done that? We've only used factoring to solve. Okay, so we've taken a quadratic, there's our standard form, and we've written it as the product of two factors. Okay, so we're going to talk about another method to factor today, but we'll get there. So the first couple slides, it's just a recap of what we've learned. So general or standard form of a quadratic, okay, that's our ax squared plus bx plus c. We've talked extensively about finding the vertex. So the x coordinate of our vertex, negative b over 2a, and then the y coordinate of our vertex, what do? We plug back in to the original function. Okay, now if we can find the vertex, then we have the vertex form of our quadratic. So let's recall with lines, slope-intercept, point-slope form, and standard form. So when we studied lines, there was three ways we could write a line. So it's not odd that there's two different ways that we could write the equation for a quadratic function. Today we're going to work with vertex form. So here's our value of a, that's our lead coefficient. Okay, and remember, I'll show on the next slide what a does. H is the x-coordinate of our vertex, k is the y-coordinate of our vertex. Okay, so the graph of a quadratic is called a parabola. If our lead coefficient is positive, our parabola opens up. If our lead coefficient is negative, our parabola opens down. This is what I started the video with. To find your x-intercepts, we set the function equal to 0 and solve for x. In standard form, the y-intercept is just the value of the constant. Okay, the constant is the number by itself. Our axis of symmetry was the vertical line through the x-coordinate of the vertex. That's what some of you missed on the form as we've been working on it. And then here's just everything put together. Axis or line of symmetry. Okay, y-intercept, vertex, x-intercepts, and then I had used this on the last video. If I look at my y-intercept is 1 unit away from my axis of symmetry. That means there needs to be a point 1 unit away on the other side of the axis of symmetry. And likewise, if I look up here at this point, so this point here is at -2. This point here is 1, 2, 3 units away from my axis of symmetry. So that means I need to have a point 1, 2, 3 units away on the other side of the axis of symmetry. So it gives me a lot of information to be able to graph these. To graph a quadratic, 3 points determine a quadratic. Okay, 3 points. So I have to see 3 points. Without question, always the vertex. Okay, the other 2 points, that depends on how you're solving. It depends on maybe if it's given in standard form, you could find the y-intercept. We talked in the last video, the y-intercept couldn't be graphed. Given the graph here, I can only go up as high as y is equal to 6 and as low as y is equal to -5. So you have to be aware of the limitations. But first and foremost, you have to graph the vertex on a quadratic. Okay, so we're going to write this standard form of a quadratic in vertex form. So first things first, a is equal to 2, b is equal to -8, c is equal to 3. So my vertex, my x-coordinate, -b divided by 2a. So I take the opposite of my value of b and divide it by 2 times my value of a. And not many people were making this mistake, but some of you. B is equal to -8, A is equal to +2. So if you need to do this in a couple steps, that's okay. The opposite of -8 is +8. 2 times 2 is 4. So the x-coordinate of my vertex is +2. Where does my y-coordinate come from? I take my x-coordinate of my vertex and I just plug it in. Okay, so I replace all my x's with +2. Order of operations, 2 squared is 4. 4 times 2 is 8. Minus 8 times 2 is 16, plus 3. This gives me -8 plus 3. So I have -5 as my y-coordinate. Okay, so now to write it in vertex form. Okay, that was on the first slide. Y is equal to a x minus h quantity squared plus k. So the three things I plug in for are a, h, and k. So I have y equals, my value of a is 2. X minus the x-coordinate of my vertex is also 2. And then plus -5 would be -5. So I've just taken my standard form and I've written it in vertex form. Now this vertex form is going to be very helpful for graphing. 2 times x minus 5. Oh, sorry about that. X minus 2 squared minus 5. Now, why the -2, even though my x-coordinate is positive? The formula, the equation for vertex form is x minus. So I'm always going to subtract my vertex. Okay, so as a little side example here, if you were told that the vertex of a quadratic was -3, 1, and I knew my a value, let's say, was also 2. Then my vertex form, a, x minus my x-coordinate plus my y-coordinate. Then what do those two negatives do? Minus and negative becomes addition. Okay, so when you write in vertex form, inside the parentheses is always the opposite sign of what the vertex is. So if the vertex has a negative x value, in the equation it would be written as a plus sign. In this example, the x-coordinate of the vertex is positive, so in my equation I write it with a minus sign. Okay, so we have a is equal to 2. We know the vertex is equal to 2, -5. Alright, so I just said if you're asked to graph, first and foremost, you got to start with the vertex. 1, 2, 3, 4, 5. So there's my vertex. A is positive, so I know my parabola is going to open up. Okay, what else do I know? Well, I started with standard form here. So if I started with standard form, I know that my y-intercept is +3. Where did that come from? Because if I replace all my x's with zeros, then that leaves me with 3, +3. So there's my y-intercept of +3. Okay, here's my axis of symmetry is through x is equal to 2. So I'm going to use that fact. My y-intercept here is 1, 2 units away from my axis of symmetry. So I have to have a point 1, 2 units on the other side of my axis of symmetry. Those are my 3 points. I'm going to connect them with an upward facing parabola, even though these are just simple sketches. And there I have it. Now, how can I prove this? Well, at this point, this is where x is equal to 4. Let me plug it into my function and make sure that I get the correct output. So I'm going to plug it into my vertex form. So wherever I see x, I'm going to replace it with 4. You could certainly plug it into standard form as well. Order of operations, I have to take care of the parentheses and exponents first. 4 minus 2 is 2. So now my exponents, 2 squared is 4. 4 times 2 gives me 8. And then I verify that I get the same y value as my y-intercept. Okay, and then lastly, now find the x-intercepts of this function. Okay, x-intercepts. I replace y with 0, and I attempt to solve for x. So let me write it again, and we're actually going to stop here because for the interest of time. So finding x-intercepts, I could also have asked you to find the roots of the function, the solutions, or the zeros. So I'm just going to continually reiterate that these 4 things all start with the same method, and that's setting the function equal to 0. Okay, so I'm going to pause here for today, and I'm going to have you work on converting from standard to vertex form for today's assignment.